In the last video, we downloaded Packet Tracer from the Cisco Networking Academy website and installed it. We also got familiar with the basic menus and features of Packet Tracer. In this video, we're going to build our first network and perform a very simple configuration. Then we'll explore the simulation environment and see how it can help us in our learning journey. If you're ready, let's get started. Let's start by building our first simple network. First, we go to the End Devices category and select a PC, then place it on the workspace. We'll add another one right next to it. To connect these two PCs, we need a switch. We go to the Network Devices category, select a switch, and place it between the two PCs. Next, we'll add the cables to connect everything. From the Connections category, we select a copper straight-through cable. Click on the first PC. It will display the available ports. In this case, we select Fast Ethernet 0. Then we click on the switch and choose Fast Ethernet 0/1 to complete the connection. Now we repeat the same steps for the second PC. Here's a quick tip. As you can see, there are many different types of cables available. If you're not sure which cable or port to use, you can select Automatically Choose Connection Type from the Connections menu. Packet Tracer will then automatically choose the correct cable and ports for you. Just click on the two devices you want to connect. As you can see, the connection is made automatically, and link lights will appear to show it's working. We wait until all the lights turn green, which means the physical connection is fully established. That's it. We've successfully built our first network. Now let's take a closer look at the devices we've added. When you click on a PC, a new window will appear. Here you can configure almost everything about the device. On the right-hand side, you'll see a physical view of the PC showing its layout, similar to an older desktop computer. It includes components like a CD-ROM, floppy drive, and the power button, which you can use to turn the device on or off. Below that, you'll find various hardware modules such as NIC, RS-232, and USB ports. We'll go deeper into these modules later, but for now, just know that the cable we connected earlier is using the NIC port. On the left-hand side, you'll see a list of available modules that can be added to the device. Clicking on a module shows a preview and description in the panel below. To add or remove a module, you first need to power off the device using the power button. Once it's powered off, you can simply drag and drop a module in or out of the appropriate slot. Let me show you. I'm removing the NIC module, and as you can see, the network connection disappears. Now I'll add the module back. And of course, I need to reconnect the cable manually. But wait, why are the link lights now red? That's because we shut the system down to change the hardware modules. To fix this, we need to go back to the physical view. Press the power button and turn the PC back on. After a few seconds, the link lights turn green and everything is working again. Let's get back to our PC. If we go to the Config tab, we can change the device name here. Next, let's switch over to the Desktop tab. This tab is designed to look and feel like the desktop of a real computer. It includes all the apps and settings we'll be using throughout this course. Out of all the tools here, two are especially important for completing our first network. The first is IP configuration, which allows us to assign an IP address to the PC. The second is the command prompt, which we'll use to test our network connection. As you may know, once two computers are physically connected, they still need a way to identify each other in order to communicate. That's where IP addresses come in. An IP address acts like a digital address. It helps devices find and talk to each other across a network. If you'd like to learn more about IP addresses, you can check out my IP address playlist to become a master at it. Now let's assign an IP address to our first PC. Click on IP configuration, and in the IPv4 address field, enter 192.168.1.1. The subnet mask will be filled in automatically. We'll leave the other fields as they are. Next, we move to the second PC. Just like before, we go to the Desktop tab, open IP configuration, and this time we assign 192.168.1.2. Now both PCs are physically connected, and each one has an IP address assigned. That means we're ready to test our network and see if the connection is working. To test our network, we're going to use a tool called ping. For those who aren't familiar with it, ping is a simple but powerful tool that helps us check network connectivity. You can think of it like saying hello to another device and waiting for a reply. If we get a response, it means the connection is working properly. But if we don't receive a reply, it usually means something is wrong. It could be a cable issue, a misconfiguration, or the device might be offline. To use ping, click on one of the PCs and go to the Desktop tab. In the Desktop tab, open the command prompt application. Here, you'll type the word ping, followed by the IP address of the destination device. Let's try pinging our second PC by typing ping 192.168.1.2. As you can see, we receive replies from the other side of the network. That's PC02. This confirms that the connection between the two PCs is working properly. Now let's try pinging another IP address. For example, ping 192.168.1.3. Since there's no device in our network with that IP address, we get a request timed out message. This shows us that no connection was made. Now, here's a quick homework exercise for you. Go ahead and add 2 more PCs to this topology, assign them IP addresses, and test the connectivity between all of them using the ping command. Now we've reached the last part of this training. And my favorite part, simulation mode. In simulation mode, you can watch the packets move step by step, for example, from PC0 to PC1, and see exactly how communication happens across the network. Let's take a quick look. First, click on the simulation button located in the bottom right corner of the screen. This opens up the simulation panel. Down here you'll see a list of packet types that Packet Tracer can simulate and display. To start fresh, click the Show All None button to remove all protocols from the list. Then click on Edit Filters. Since we're going to use the ping command to test connectivity, select the ICMP protocol to filter. Now we'll only see ICMP packets, which are used by the ping tool. To start the simulation, we'll run a ping test from PC0 to PC1. To do that, go to PC0, open the Desktop tab, and then launch the command prompt. Now we'll ping PC1 using the IP address we assigned earlier. As you can see, an envelope appears next to PC0. This represents the packet that's about to begin its journey to the destination, PC1, through the first hop, which is switch 1. If you click on the envelope, you'll see detailed information about the message. In the first tab, you'll see how the packet travels through the layers of the OSI model. In the second tab, you'll find even more detailed information about each layer's header. For example, in the IP section, you can view the source and destination IP addresses of the packet. To watch the entire packet journey in one go, click the play button. But if you want to follow it step by step, click the next button to move through each hop. Now our packet reaches the switch. Again, you can click on the envelope to view the details of the packet at this point. Click Next again, and the packet will arrive at PC1. Now, PC1 should send a reply back to PC0. Let's use the play button to watch the return journey of the reply packet. That was the journey of an ICMP packet, which is what the ping command uses. Later on, as you learn about more protocols and build larger topologies, you'll realize just how useful simulation mode is. It's a powerful tool for gaining a deeper understanding of how networks operate behind the scenes. To exit simulation mode and return to normal operation, simply click on the Real-Time button. That's all for this video. I hope you enjoyed it and learned something new. If you found this helpful, don't forget to like and subscribe. And if you have any questions about Packet Tracer or suggestions for future videos, just let me know in the comments. I'd love to hear from you. Thanks for watching, and I'll see you in the next video.